Now, in part one, we talked about these friends going to a movie theater and the different seat combinations that they could have. And we talked about how important order was. That if person A wasn't sitting next to person B, then that was completely different setup and a completely different order. So what's taking place now is in this particular section, in this part of the section, order isn't going to matter so much. And we'll give an example of why order doesn't matter. So let's talk about these friends going to a pizza parlor. And you know, if you go to a pizza shop, you have several toppings you could choose from. All right, this pizza parlor has peppers, onions, olives, mushrooms, pepperoni, sausage, and ham for their toppings. Now, suppose I wanted to have 2 toppings of vegetables on my pizza. So I want to list all the combinations of the different vegetable toppings that I can have. The ones that I've underlined here, we're talking peppers, onions, olives, and mushrooms. Those are the vegetables that I can put on my pizza. So let's look at the different combinations. All right, the different combinations we can have are peppers and onions, peppers and olives, peppers and mushrooms, onions and peppers, onions and olives, onions and mushrooms, olives and peppers, olives and onions, olives and mushrooms, mushrooms and peppers, mushrooms and onions, mushrooms and olives. This takes care of all the different possibilities that we can have on our pizza. The problem with this list that I generated is there is no difference between a pepper and onion pizza and an onion and pepper pizza. Like, it really doesn't matter which order you call it, right? If I say I want olives and mushrooms on my pizza, and my friends say, well, I want mushrooms and olives on mine, it's the same thing. It doesn't matter who says which vegetable first. The fact is that both vegetables will appear on the pizza. So because order does not matter, right? A mushroom and onion pizza is the same as an onion and mushroom pizza, that some of these things are repeating. So we need to get rid of the ones that are repeating. So here it is. I have pepper and onion pizza. So I need to get rid of the one that says onion and pepper pizza. So I don't want that one. Here it is. I have a pepper and olive pizza. Get rid of the one that's olive and pepper. Here it is. I have a pepper and mushroom pizza. Get rid of the one that's the mushroom and pepper pizza, because once again, it's the same. So I'm just going to go through and get rid of the ones that are repeating. So as you can see, my list breaks down to only 6 things now. 6 different combinations. So the answer to the question is how many different combinations we can have. The answer is 6, not 12 as we originally came up with. Combinations are groups that do not need to be ordered. So in this particular example, those were examples of combinations and not permutations. Now, the formula we're going to use for this is really quite simple. It almost looks the same as the other section, except it is a C instead of a P, because once again, we're talking about combinations here. And the difference, once again, between combinations and permutations is combinations, order does not matter. It is not important when we're talking about combinations, order is. So it almost looks the same. You have n factorial over parentheses n minus r factorial, except there's also another r factorial at the bottom. So this extra part right here is included on the combination one. And remember, combination is different from permutation in the fact that order is not important. in this particular section. All right, let's do the problem we just got through doing using this notation. So we know that we have we're talking about a combination. There were 4 possible toppings that were vegetable toppings, and we wanted to group them in 2s. And once again, we talked about how order doesn't matter. So what we're going to have at the top is 4 factorial over 4 minus 2 factorial, 2 factorial. So that's 4 factorial over 2 factorial, 2 factorial. So that's 4 times 3 times 2 times 1 over 2 times 1. That takes care of the first 2 factorial times 2 times 1 again. And we can cancel out here. This and that one will take care of that, which will leave us with 12 over 2, which will once again give us our 6 toppings. Let's continue to use our example of the pizza toppings. Now suppose this time I wanted to consider all 7 toppings, and I want a 3 topping pizza. So I get to choose from any of the 7, and I want a 3 topping pizza. So once again, we're going to use our notation. We know that order is not important, so I'm going to have a combination. I have 7 toppings to choose from. I get to place them in any order in 3. So that's going to give me a 7 factorial over 7 minus 3 factorial, 3 factorial. So that's 7 factorial over 4 factorial, 3 factorial. And we write this out. That would be 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 4 times 3 times 2 times 1 times 3 factorial, which is 3 times 2 times 1. I'll go ahead and cancel these out. And that will leave me with, do this correctly, 7 times 6 times 5, which is 210 over 3 times 2 times 1, which is 6. And this reduces to 35 3 topping pizza. Combination.